When building end-of-life technology, engineers face a severe contradiction. The system must guarantee an absolute, multi-generational data permanence, but it must capture that data from users operating under the extreme emotional volatility of grief. Standard consumer web architectures fail under these constraints. Social media platforms and generic website builders rely on temporary cloud hosting and expose sensitive inputs to third-party ad tracking scripts, making them unviable for secure, long-term legacy storage. Virtual Obits operates as a full-stack legacy pipeline. It relies on a React 18 frontend, Zustand state management, and Gemini AI narrative processing. From this, the engine compiles 6 distinct output layers, ranging from web displays to permanent laser-engraved steel plates. To ensure total privacy, the platform explicitly isolates this user data from the broader internet ecosystem. There are no tracking pixels, no retargeting mechanisms, and no shared databases. The objective of treating memorialization as an engineering challenge rather than a consumer design task is to build data sovereignty and digital dignity directly into the architecture itself. The pipeline begins with an accessible 8-step data ingestion wizard built on React 18 and styled with Tailwind CSS to ensure a responsive, low-friction environment. This interface captures the initial visual direction of the memorial, collecting cover photo uploads and design preferences before asking for heavy biographical text. From there, the system moves into chronological data ingestion. Clean, isolated input fields capture essential biographical details, like the name, date of birth, and place of residence. Because users are operating under extreme emotional and cognitive load, losing a paragraph of text to a standard web session timeout is an unacceptable failure state. To solve this, the architecture implements Zustand State Persistence, guaranteeing continuous client-side autosaving into local memory without a server ping. Managing state locally isolates sensitive inputs from external tracking scripts. This approach enforces strict data sovereignty, keeping data encrypted and never routed to targeting networks. At the end of the ingestion phase, the user locks their finalized data, preparing it for handoff to the processing layer. The verification interface clearly displays the locked data points alongside the generated output, allowing users to confirm that every biographical detail has been captured accurately. In end-of-life technology, robust state persistence is the foundational mechanism of ethical data protection. Once the state data is locked, the front end securely hands the raw JSON payload over to the back-end processing engine. The primary driver for narrative generation is the Gemini 3 Flash model. To prevent inappropriate outputs or large language model hallucinations, the system's prompt architecture is strictly and contextually tuned specifically for end-of-life content. The engine parses a raw list of dates, locations, and hobbies, weaving those disparate data points into cohesive, empathetic obituaries and eulogies. This interface shows the model's capacity to handle complex ceremonial sequencing, automatically structuring and formatting the order of service, including invocations and musical selections. Running in parallel is a dedicated visual processing layer powered by Gemini 2.5 Flash image. Users interact with this visual layer directly through the dashboard, entering simple text prompts to generate thematic background art for the memorial. The resulting visual assets are entirely text-free, customized to match the specific tone and atmosphere the family wants to convey. The system then harmonizes these generated visuals and user-uploaded photos, offering automated layout styles like grids or rounded borders to unify the presentation. In this view, the user validates the AI-generated narrative. The interface highlights matched biographical details directly in the text to ensure chronological and factual accuracy before finalizing the document. This dual-model AI pipeline reduces the massive cognitive load of memorial creation from several hours to just a few minutes, while maintaining professional narrative quality. With narrative and visuals locked, the engine enters the compilation phase, routing that identical JSON payload into 6 parallel output streams. Layer 1 is the core HTML memorial site hosted on VirtObits.com. Layer 2 is the interactive digital flipbook, designed for remote sharing. Users control and deploy these digital outputs through a centralized dashboard, utilizing quick copy links and scannable codes to distribute the flipbook instantly. Layer 3 compiles a presentation slideshow, formatted precisely for live display on screens during the physical funeral service. Layer 4 creates the PDF archive. The platform utilizes the JS PDF library to generate high-resolution, print-ready files directly from the browser. This requires smart pagination logic to calculate text flow, automatically splitting long eulogies across multiple pages with professional continuation indicators. Layer 5 takes that same formatting logic to generate the memorial card sheet, automatically paginating multiple wallet-sized handouts onto a single print surface. Every printed card incorporates an integrated QR code, creating a direct link back to the core HTML hub in Layer 1. Finally, Layer 6 is the most resilient output format, the physical-to-digital bridge. The system generates precise vector files for a 3x3-inch stainless steel plate, designed to be permanently affixed to headstones. Forged from AISI 316L industrial steel, the plate possesses extreme environmental resistance, maintaining structural integrity against acid, saltwater, and extreme temperatures for up to a century. Compiling synchronized outputs across both cloud hosting and industrial steel creates an unbroken, multi-generational chain of custody for the legacy data. Out in the real world, this architecture yields a seamless physical-to-digital experience. A visitor uses their smartphone to scan the stainless steel QR plate. The scan triggers an immediate routing request, authenticating the device and querying the secure HTML site for the stored data. The user's device instantly receives the interactive flipbook, presenting the complete AI-generated narrative of the subject's life. Granular ceremonial details, such as the exact order of service and specific scripture readings, remain permanently preserved and accessible from anywhere. By combining robust state persistence, context-aware large language models, and multi-format document generation, the system successfully resolves the operational friction of grief. The platform executes on a strict thesis of data sovereignty. The user entirely owns the legacy, whether it's encrypted in a database, printed on archival paper, or etched into steel, and it remains completely free of ad tech interference. Virtual Obits demonstrates how modern full-stack engineering establishes permanent systems of digital dignity.